like he said, my name's Keith Gautreaux. I am a physician by trade, and I work in Pullman, Washington for an electrical engineering firm providing on-site healthcare for employees and their family members. So Pullman is basically down here by the 8 there. And it's my pleasure today to talk to you a little bit about Phoenix Presence. But the talk isn't exactly about Phoenix Presence, although we will touch on it a little bit. It's more about designing fault-tolerant systems, specifically as it relates to healthcare. It's also a little bit about the project and how those two things dovetail together. It's a little bit about the mistakes that I made in the project. And then it's a lot about the analysis of Elixir, Phoenix, Erlang, OTP, and how those can encourage the design of systems that enable success even for inexperienced programmers. And I've got to tell you that my talk is so good that it actually traveled back in time and caused Jose to change the goals of Elixir. So if you saw the keynote today, a lot of the things that he touched upon, maintainability and reliability, are going to be exactly the things that I'm going to talk about stressing as we build tools and frameworks to help extend Elixir and Phoenix into the future. So hopefully it won't be redundant. But before I talk about that, this is my mom. Hi, Mom. My mom, before she retired, was a speech coach and a teacher. We used to call them speeches back then. Now we call them talks because we like to verb every noun. But my mom is a speech coach, so anything that is good about this presentation is solely due to her, and anything that is bad about it is due to me. But on August 17th of this year, my mom suffered a massive right middle cerebral artery stroke, and she's currently recovering in a rehab hospital in Nebraska. So this talk is dedicated to my mom, and I'd like to wish her a quick recovery. One thing that I see at every medical lecture that I've ever attended, but which I've never seen in a technical talk, is a disclosures section. At the front of every medical lecture, you'll get a section for disclosures where the speaker will list their biases, basically. I like to start that trend in technical talks, so I'm going to have some disclosures at the start. I have no financial disclosures, I have no financial biases, and this is the section where every medical lecturer is required by law to make the joke that they have no financial conflict of interest, but if anybody wants to give them one, they can come up after the talk and they can offer money. The second one is that this is my first conference talk, so I thank you for attendance and I thank you for your attention. The third is that this talk should not be construed as medical advice. We're not going to talk a lot about medical topics. I am a physician by trade, but we're mostly going to talk about software systems, but I felt compelled to say that at the outset. And then the most important disclosure that I want to make is that I am bad at Elixir. I am a self-taught programmer. I'm relatively inexperienced, and most of the time, I wouldn't be the one up here on this soapbox talking to you, but I want to advocate for my kind. Because what I want us to do is to think about me, think about the people at the bottom half of the bell curve in aptitude when we're designing our frameworks and our tools and our libraries, because my feeling about why Jose started Elixir in the beginning was he saw the golden panacea of Erlang and OTP, and he needed to build a bridge to cross the chasm between us and the amazing technology that we see there. Those things are great for building awesome systems, and particularly healthcare software, and it is incumbent on us to build the tools that help us get there. So our movement even has a chant. It's, what do we want? The pit of success. When do we want it? Oh. So Jose is so good, he even ruined my joke with the keynote, because in Elixir 1.5, the bottom part of the error message would tell you exactly what you did wrong, and then you get to fix it, which is exactly the point that I want to make. That is exactly the type of thing that we need to be doing, because no matter what we might think about our framework and library code, we need to think back to the beginners, the people just being introduced to our frameworks, the ones at the bottom part of the bell curve, whether that be due to time constraints or whatever else, that we need to shuttle along into the top part of the bell curve, because they're going to be replaced by people coming along to the bottom right behind us. Right? I think this is best illustrated by the old joke, which is, what do you call the person that graduates last in their medical school class? That's right. You call them doctor. When we assess people's self-assessment of their driving ability, over 75% of people say they're in the top half of driving ability. And so, that probably illustrates a misunderstanding of statistics and normal distributions, but it also illustrates the endless human capacity for self-deception. We need to understand that there are those of us in the bottom half of the bell curve. We need to own that, and then we need to think about, how do we help those people? Your code will be used by below-average programmers like myself, and I want you to think about that. This is a landmark report by the Institute of Medicine that was published in 1999 called "To Err is Human." And if you want to be even more frightened than Googling your current medical symptoms, you should read the first paragraph of the executive summary of this report. In the second sentence, it specifically says that between 44,000 and 98,000 individuals die every year because of medical errors. That means that a jetliner's worth of people are dying every day because of errors in healthcare. Now, that was 1999. There's a follow-up report in 2001 called "Crossing the Chasm," and it talks about specifically, so does this report, but that report is more specific about the reason for the medical errors is not individual fallibility, because the people that provide health care are not dummies, and they're not trying to make patients unsafe. The reason that medicine is unsafe is the accretion of systems that are designed to make it difficult for people to be successful. Medicine is, by my estimation, anywhere from 28 to 50 times older than computer science. So what I want to do is I want you guys to learn from the mistakes that older scientists have already made and avoid those potholes where you find them in the road. What we suffered from in medicine, and I see the same sort of things reproduced sometimes in software development, is that the goal of individual exceptionalism blinded us to how our systems were killing patients. When you're competing with other medical students, you're always told that you're exceptional. You're always trying to be at the top of the class. But you don't think about going out and designing systems for those of your peers who graduated at the bottom. Don't let individual exceptionalism blind you to the fact that not everybody's going to be in the top 1%. An above-average team can overcome a bad system, but a bad team cannot. And imagine if we had a good system, what great teams and even average teams could do. So, I'm going to tell you a little bit about who I am. I am a physician by trade, but I'm a self-taught programmer, as I mentioned. And I work for an electrical engineering company. So I wear many hats, and in people, I think leaky abstractions are actually good. You get a big stack of Oreo cookies and all of the filling bleeds down through the chocolate. It's delicious. Leaky abstractions in software can be bad, but we know all abstractions are somewhat leaky. But leaky abstractions in humans are good for a few reasons. I think we all suffer sometimes from imposter syndrome, but I think one of the best antidotes for imposter syndrome is to know your niche. I would be willing to wager that I am the best primary care physician at ElixirConf. I know I'm not the best programmer. I might be the worst, but I know that my niche is in healthcare, is in medical care, right? And so whether your niche is you're a plumber or you're a neuroscientist or any of those, use the experience you derive from your niche to help inform how you improve your ability to deliver good software and design good systems. So what do I want? Well, my goals with the talk are basically twofold. I am not good at Elixir, but I have domain-specific knowledge, and I have a problem to solve. So how do I solve that problem? That's one of my goals, and I want to tell you about the project. But my secondary goal is to convince you to write and open source libraries that think about that bottom half of the bell curve of people like me and extend the things that Jose was talking about today to make sure that we favor reliability and safety now that we have this really ergonomic and easy to use language and frameworks like Phoenix that allow us to solve some of these problems that previously we couldn't solve. Why do I want that? Well, I think I've covered that a little bit already, but my job is really great because I work for a company providing on-site healthcare, and I don't charge for any of my services. So when I think about how to design a healthcare system to be delivered in my clinic, I'm not encumbered by determining what the ROI is for any of those interventions. I'm freed up to think about what is the way that I can best deliver quality healthcare regardless of the cost. And that was the original impetus for the system that I'm going to describe. So can Phoenix help me? I want to improve the healthcare that I deliver in my clinic through data-driven decisions. And I want to study specifically how much face-to-face time does the provider and the patient have in the average clinic visit, and how do patients and providers flow through the clinic in order to change the way that that works, because we don't have to worry about making every visit 7 minutes long so that we can charge revenue, so that we can generate the profit that enables the clinic to stay open. So this is the pipeline of a patient visit. So the patient shows up, they're checked in. We're using room here as a verb because that's common parlance in medicine. They're taken to the exam room. They have their vital signs taken. They're evaluated then by the provider, and that's the time that the provider and the patient may spend in the room together. Then they may have testing or labs drawn, and then they'll be discharged. So we have a fair amount of data about how face-to-face time with providers affects patient satisfaction surveys. We know that more time with the provider, more patient satisfaction. Great. But we don't really have any studies about how face-to-face time with the provider affects the quality of healthcare or the healthcare metrics. So does that result in lower blood pressures when you spend more time with a hypertensive patient? Does that result in better glucose control when you spend more time with a diabetic patient? We don't have that data. And the studies that were done on patient satisfaction surveys were subjectively done, right? So that introduces bias. Basically, you just ask the provider or the patient, how much time did you guys spend together face-to-face in the room, right? So documentation burden on providers is already immense. I don't want them to have to also at the end fill out a little thing that says how long they spent with the patient. So I want to be able to do that in the background, and I think Phoenix Presence can help me with that. Time is the most precious resource in primary care, even other than subspecialties, because you have so much to cover and you have such limited time with a patient. So we want to know how much time they spent face-to-face and where is that flow being disrupted, and we want it to be passive collection. We don't want to force people to fill out forms. So we want to detect the duration in each of these stages. And we don't want to lose sight of the goal, which is actually to improve healthcare quality, or at least study how we're delivering that. We want to aggregate the data and analyze it. So let's talk a little bit about Phoenix Presence, just an overview. If you've attended Chris's training, you know more about Phoenix Presence than I do. But just as a brief overview, and you should watch Chris's talk if you haven't, because it tells you how to use Presence. Phoenix Presence is a module that implements the tracker behavior from the tracker module, which is part of the PubSub system. And as everything basically does when it needs to store state in a mutable functional language, like Elixir, it uses a gen server to basically store that state. And then it manages it using CRDTs, which are conflict-free replicated data types. We're not going to talk a whole lot about that, and you can read the paper free replicated data types basically sacrifice consistency for availability and partition tolerance in the CAP theorem. And then eventually they become consistent, right? So node goes down. Eventually you want it to be consistent, but you care more about availability at the time. This is the paper, and you can read it if you'd like. So what is the nidus of the implementation? We're going to introduce a little selection bias because we're just going to use iOS clients because David Stump has written a great Swift Phoenix client to install on the device and then track the proximity to Bluetooth beacons. David presented at ElixirConf 2016 about Swift Phoenix client. It basically allows iOS to communicate over Phoenix channels to the presence functionality. We're still in the implementation phase and the pilot phase, so I don't have any data to share with you currently, but that's the essential gist of the way we're trying to do the study. So now I have an additional disclosure, which I didn't state at the start, which is that I'm going to list some problems that I ran into, and you should know full well that these are wholly problems of my own making, and in no way the responsibility of the dedicated individuals like Jose, like the core team, like Chris, like the core team that work on this every day, or any of the individuals who work on the Phoenix guides or anything of that nature. So my first mistake was not to build a chat app. Because Phoenix Presence is such a new feature, all of the documentation, all of the blog posts are basically how to build a chat app. And in most cases, how to pass the name in the params so that you can display the name, right? As a programmer in the bottom half of the bell curve, blog post-driven development is how I do everything, right? Because I am not knowledgeable enough to come up with solutions de novo. So if the solutions presented to me stop there, it's hard for me to work past that, right? So part of making it friendly to beginners, I think, is understanding that these sorts of documentation we need to flesh out. And that's things that all of us can be involved in, myself included, right? So I am wholly not without blame here. I would like to thank Daniel Burkumpus for his Learn Phoenix video series, which I would encourage you to watch if you haven't, because it talks a little bit more about presence and gives some additional feedback. Second was not attending Chris's ElixirConf training. Chris is so far on the top half of the bell curve that he does that whole thing live. He codes the whole thing live to teach people how to use presence, which is amazing and awesome, but it does have the downside of we don't have artifacts at the end of that training that we can then disseminate to the community at large. So, that's certainly a downside, but we have people that have knowledge that have now gone through Chris's training and a network effect that they can then go on to write things that I can use to build the stuff that I want. So if you went to Chris's training, please write up something. Not reading the source. For beginning programmers, this is a frequent mistake, but the source not only has the hex docs documentation in it, but it also has the implementation. You can see the shape of the code, and you can look at the doc tests, and you can get an idea of how you're supposed to use it. The Phoenix guides, which are amazing and awesome, and I had to use extensively, don't mention presence in the channel subsection. But they've been continually improved, and so everybody that was here at ElixirConf on Wednesday, except for Chris, submitted a PR to the guides to help improve them. So we should continue to do that. But right now, you need to read the source. And also, assuming that doc tests mean broad applicability. So Jose also already addressed this. Basically, doc tests ensure that your code, the demonstration in your code is internally consistent because it'll run that code and say, did you get the result that you wanted to get? But it doesn't ensure that similar code between two modules in your doc tests is compatible, right? That it's synchronous. You may do it one way in one module and another way in another. So I am super excited about the possibility of doing property testing on doc tests or running generative tests so that you can see, okay, I didn't understand this aspect of this corner case in this doc test, and enable basically synchronicity between doc tests and modules. The pit of success is a term coined, I think, by Rico Mariani, who's a common language runtime researcher at Microsoft. It was popularized by Jeff Atwood. And the pit of success is something you get inexperienced people, or sometimes even experienced people, to fall into, to make it hard to stay out of the pit of success through the ergonomics of your language or your framework or those sorts of things. So I want us, as we build tools, to always be thinking about the pit of success. And not only the pit of success in general, but what is the performance pit of success? What is the safety pit of success? How can we get people to fall into those things as they're leveling up in the language and in the frameworks? So let's talk a little bit about the pros and cons of Elixir, Phoenix, Erlang, and OTP as it relates to healthcare software, because that's what I care the most about. So many of you may know that the Health Insurance Portability and Accountability Act covers electronic health information in the United States. So that statute has two sections, a privacy rule and a security rule. The security rule covers electronic health information. And the security rule doesn't tell you that you have to use encryption at rest for your protected health information. But if you're going to not use it, you need damn good justification why you decided not to do that. So we should make it easy for people to fall into the encryption and security pit of success. And another library by Daniel Berkampas, Cloak, allowed me to encrypt the data at rest that I'm collecting from this. So I encourage you to use that library. It makes it very easy as data flows through Ecto to encrypt it, store it in Postgres, and then decrypt it as it comes out. And you can actually even use hash fields to make the data searchable, even though it's encrypted in the database. So I encourage you to contribute to that library. Jose talked a lot about ergonomics today, maybe even if he didn't mention it specifically. And I think Elixir is a unique opportunity to allow ergonomics that encourage people to design great systems, even if they may not be 20 years experienced in their particular field. And Phoenix contexts are another great example of ergonomics that cause people to fall into the pit of success. So if you're using context in Phoenix 1.3, they'll allow you to make separation of concerns of your business logic that will route you around potholes later on down the line. A perfect example of helping beginning programmers or people in the bottom half of the bell curve like myself fall into the pit of success. This, of course, was actually on the Elixir goals. So again, time travel. If you've ever used an electronic health record, I'm sorry, but you know that one of the first troubleshooting steps is to reboot the system or log in again. And this is true of a lot of software, but I really want to stress the freedom and the comfort that comes from having truly reliable software to work on. There's no cold sweat like the cold sweat of typing into a text box the documentation for your visit, for a 30-minute visit with a patient, and then seeing that disappear. And now you have to recreate all of that documentation. There are incredible opportunities that arise when people start to get comfortable with their tools. Right now, all providers hate their electronic health record. They hate medical software in general. The average provider spends 2 extra hours a day compared to paper charts documenting in electronic health records. What I would like for us to try to work on achieving in healthcare, and I think these tools are the way to get us there, basically is to make sure that people are so comfortable with it that they come to rely on it and they act more as pilots supervising an autopilot rather than people dealing in the minutia of documenting every single part of the visit. In order to achieve that, people have to trust that the system works well and they can rely on it. And then the last thing I want to talk about is scalability. And specifically the way that scalability relates to saving money in healthcare. There are about 1 million physicians in the United States. So if we take WhatsApp's published data about their service, they support about 1 million devices per server. So let's over-provision and add a second server. Now we're serving all the physicians in the United States. Obviously, market forces will not allow this to be true, but it gives you an idea of how much we could support with much less infrastructure resource. Healthcare spending in the United States is approximately $3 trillion. It is the largest portion of our gross domestic product, and we don't get the best quality of healthcare even despite that expenditure. Healthcare IT spending is about $35 billion a year. So even small changes in that amount of money, a dollar here, a dollar there, pretty soon you're talking about real cash. So by building scalable systems, we can bend the cost curve. We can use that money to deliver actually quality healthcare that helps people live better lives. I think that's a tremendous goal to have. We'll talk a little bit about the cons. Of course, Jose eliminated most of these. Chris has been working tirelessly to eliminate them, but I'm going to talk about them because it's incumbent upon us to now take that and run with it now that these guys have started it. So when I talk about extensibility, I'm specifically speaking more about like native implemented functions to C++ machine learning libraries, because if you're going to build a healthcare system where the provider is acting as the pilot, supervising the autopilot, and not the one doing the dirty grunt work of every individual documentation, you have to have some machine learning or algorithms that will allow you to collect that data without supervising it or babysitting it. Novelty, of course, is always a problem with a new language and new frameworks, but I think the attendance here is good demonstration that that's becoming less and less of a problem. So now it's time to think about the next 600 people that come along after us, and how do we design the tools to make sure that they fall into the pit of success. And then I'm going to speak a little bit about interoperability specifically relates to healthcare software. This is a huge problem in healthcare. There are libraries for Elixir to interface with fast healthcare interoperability resources, which is basically just, let's try to build a REST API for health software because nobody's tried to do that before. And Jeff Ching has a program to use Swagger or Open API to try to auto-generate some wrappers and tools to enable any API that's compliant with the Open API spec to achieve this. But when you're dealing with programmers like me in the bottom half of the bell curve, when we look at API, we're going to look at the libraries that are already there, and we're going to use one of those. We're not going to build our own, of course. So we have to make it an easy drive-through window decision where, OK, I see that Elixir's on there. I see that I can use that, right? We can help people fall into the pit of success because we know all about the benefits of using Erlang and OTP. But it's hard to just communicate that to people. You have to make it easy for them to do that. So the reason I get so excited is because I think that the tools that we have here and the platform that they're built upon provide endless potential for making the impossible possible, but the previously unachievable easy for people even in the bottom half of the bell curve, right? Like all great tools, like the Gutenberg press, it makes something that previously couldn't have happened possible. But crossing that chasm is up to us to get there, right? So we have to think every day about how beginners use our tools to make sure we're designing the best tools to enable people to fall into the pit of success. And then last, I'm going to give a little spiel about not only the business case of hiring people to work on open source software. So I'd like to thank Dockyard and Plataforma Tech. The business case for hiring people like Chris to work on Phoenix is that if you're Dockyard, this is a tool that you rely on for your business, and more use of that tool or having a better tool provides a business case going forward that justifies your support of that person. But I want to encourage companies to not just think of the business case. I know that's hard for companies, but I also want to talk about the human case. Because when you fund somebody to work on tools like that, you never know when those tools might be used to save someone's life or improve the health care of someone, fellow humans. So I encourage companies to think about the human case when they're thinking about funding open source software and dedicating people to work on it. So with that, here are my references, and there are the image credits. So if anybody has any questions, I'd be happy to take them. Thank you.
The intersection of being a medical doctor and programming seems like it doesn't happen very often. What caused you to kind of move your interests and expertise into Elixir and Nerves, or not Nerves, but Elixir and Phoenix to solve this problem?
Yeah, so like I said, I'm a self-taught programmer, but like most physicians, I am a nerd since birth, right? And intellectual curiosity makes me interested in computers. And so I am self-taught originally in Ruby using Chris Pine's Learn to Program book, right? So then got into Rails and, of course, knew Jose from the core team. But the thing that got me excited about using Phoenix for this project was specifically the presence feature, which is unique. So I know enough about engineering to know that you should choose the right tools for the job, right? That's a good mantra to adhere to. So that is a tool for the job that as a programmer with limited time and limited skills, I can see how that can allow me to build something that otherwise I could not build, right? So that's the reason for using Phoenix and Elixir. I hope that answered your question. Thank you.
More questions? I have a question. You mentioned machine learning. What kind of pushed you in that direction?
So Chris and I sort of discussed this before. It is a mistake to chase the white elephant of building an electronic health record. Many people have gone before you and perished, so avoid that. But over the course of time, I think we can build systems that allow interoperability between the systems we already have and allow. So one of the things about to err is human is that the systems are the cause of the failure. So one of the things that arose out of that is now medicine is much more like flying an airplane, where we have checklists before we do a surgery so we don't operate on the wrong limb. Right? That all came out of pre-flight checklists and all those sorts of things to move our system to be more like a pilot pilots a commercial airliner and less like take one individual who's supposed to remember everything in their head, right? So I think that if we're going to add that additional documentation burden, we need to find ways to make it easy to passively collect data about the patient's health and then allow the provider just to supervise it. Right? And so to do that, you need machine learning algorithms and those sorts of things to make sure that what the provider is seeing is aggregate information, right? And they can spend all of their time in the visit talking to the actual patient. They can spend even more face-to-face time, which improves the patient satisfaction and probably improves the quality, which is what we're trying to study.
We've got time for more if you guys have questions.
Hi, great talk. I was wondering about how you managed to make the adoption of your tool, of your new practices, a reality, because I'm also in that field in the healthcare, and being a very regulated industry, and also customers, well, our customers, like big pharmaceutical companies, they're really against change. You know, we're always trying to push new versions, new features that make cost savings, things easier, faster, and just better. But they're just like putting the brakes on and be like, we don't want this, it works, don't touch it. I know it's shitty, like the UI is too old, whatever, whatnot, but it works, don't change it. So what is your experience in that?
Yeah, so I think the first great strategy is a great engineering strategy, which is to narrow the scope as much as you possibly can, right? So this is, I'm the medical director of this clinic, so I kind of have carte blanche to say, this is how we're going to do this thing, right? If I'm trying to bring this product to market in the healthcare system, that's totally different. But I see that we have the advantages of the Erlang and OTP platform, which would allow us to build reliable software, which is basically what your customers are telling you, don't touch it, we think it works right now, right? But it's up to us to be able to see those things, because there's no way we can carry people on that journey from the start to the end. They have to kind of trust us. How do you get people to trust you? You know, in consulting work or in product development, I think it's the same way you get people to trust you in any way is you show them continued success so that they buy into seeing you as someone who doesn't lie to them. right? You know, their heart has been broken repeatedly by horrible systems, right? And so they've vowed that they'll never love again, right? So you need to, that's what I'm talking about reliable systems is eventually, you know, we can get people to understand that it doesn't have to be this way in software. We can build reliable systems, but they need to be even exponentially more reliable than we consider the systems that we use now to build web apps in order to get people past that chasm and say, this is something I can depend upon, just like I can depend upon a reflex hammer to always give me a reflex, or a blood pressure cuff to always give me a blood pressure reading. We won't talk about the variability of those sorts of tools, but I think, you know, that is a very hand-wavy answer to what you asked was a very serious question, but there's really no easy way to cross that chasm except to go on the journey, right? So piecemeal.
So if this is what the bottom of the bell curve looks like, I think that we're going to be okay. That's a brave talk, an excellent talk.
Thank you.
Round of applause.
Thank you.